So we're going to be doing our notes for 7.6, which is the fundamental theorem of algebra. And for your notes, when you're getting your this page set up, I would suggest when you create this table on your own paper that you make it like a full sheet of paper. This is going to be just a really important page of notes. I wish I had it bigger and more spread out. So I would just recommend that you do that. Start on a fresh page for these notes. Right, and let's just go ahead and get started. We're going to be comparing these three graphs and just learning a bunch of information as we go through that. All right, so as we look at this, let's go ahead and put the equations into y equals. We'll do them one at a time. I would ask that you put your calculator window, I'll show you here. You want to put the window for your calculator on a standard window, so that's -10 to 10. And then you're going to go to y equals, and you'll type in that first equation. And this is just going to be a sketch. This graph does not need to be perfect. We just want to be able to see some key points in it. That's all we're looking for. We're going to hit graph, and there it is. So it's a quadratic that hits the x-axis twice, and it dips just a little bit below, not very far below. It looks like it dips below right there at -1. And it crosses the x-axis at 1 and 3. And I can't really tell in this picture of the graph, but if I look here at my equation, I can tell that my y-intercept is 3. So that's a lot of key points that will help me draw this sketch. So we said the y-intercept is at 3. The x-intercepts are at 1 and 3. And it dips below at -1. And that's enough for me to draw a nice sketch of that quadratic. Okay. All right, let's go ahead and just do all of our sketches first and get those out of the way. All right, so I'm going to go to y equals. I'm going to clear out this equation, and I'll put in x squared minus 4x plus 4, and I'll hit graph. And it looks like this one only hits right there at 2. Its y-intercept, according to this, is going to be at 4. And so there's the picture of that graph. All right, now let's go to my third one. Clear that out. We're going to do x squared minus 4x plus 5. And look at that. This one doesn't even hit the x-axis. It looks like its vertex is at 2, 1. And its y-intercept is at 5. I'll just kind of draw a little sketch like that. Okay. All right. So let's fill out what we can here with what we already know. Real zeros, by the way, when it says real zeros, that means zeros you can see on the graph. That's why they're real. Okay. This one right here has 2 real zeros. This one has 1 real zero. You can only see 1 there. This does not. Zeros, remember, are x-intercepts. This one has no real zeros. Right, then it asks for what are the zeros and what's their multiplicity. We're going to talk about that in just a second. So the zeros for this first one were 1, 0 and 3, 0. This one here was 2, 0, and I don't know yet what this is. My factors, since I know my zeros, I know my factor must be x minus 1 and x minus 3. And sure enough, if I was to multiply this out, I would get x squared minus 4x plus 3 The degree of this polynomial degree is the highest exponent, is 2. All right, since this is a 0 that's, this 0 is 2, this factor must be x minus 2. And there's only 1. And that's because in order to get x squared minus 4x plus 4, you have to multiply x minus 2 times x minus 2. Which means this 0 has a multiplicity of 2 because it occurs twice. This 0 technically counts twice. So it still has 2 zeros. It has a multiplicity of 2. Each of these factors occurs once, so these each have a multiplicity of 1. Because the factor occurs once, therefore the 0 occurs once. If the factor occurs twice, the 0 occurs twice. We say it has a multiplicity of 2. This also is a second degree polynomial. Now I don't know if you're starting to see a pattern here, that we have a second degree polynomial and we have 2 factors, so we have 2 zeros. We have a second degree polynomial, we have 2 factors. We have 1 0, but it has a multiplicity of 2. We only have 1 real 0, but again, it occurs twice. So 1 real 0 with a multiplicity of 2. Remember, let's just remember that it's a multiplicity of 2. It occurs twice. So it still amounts to 2 total. Now this has no real zeros, but it's got to have some kind of solutions, which means it must have complex zeros. And we're going to have to see, are they the same complex zero? Are they different zeros? So we know that we're going to have some kind of complex zeros. Let's figure out how many. We know that this is a second degree. I don't know the factors. I don't know the zeros. So in order to find my zeros, I'm going to need to use the quadratic formula to find those. And we're going to do that in just a second. Let's talk about this very first part. It's called the discriminant. The word discriminant looks a lot like the word discriminate. And to discriminate means to make a judgment based on something. So you're looking at something and making a judgment. And though in our society we think of discriminate as a very negative thing, in math we discriminate, we make a judgment based on something mathematical. So in this sense, it's not a negative connotation. So the discriminant is one piece of the quadratic formula. It's the quadratic formula, b squared minus 4ac. That is the discriminant. It's the part of the quadratic formula, x equals opposite of b plus or minus square root of b squared minus 4ac all over 2a. And what we find is, because it's under the radical, its sign tells us how many real zeros we're going to have. So let's look at the discriminant and see what I mean by this. So let's look at b squared minus 4ac. So a would be 1, b is negative 4, and c is 3. So the discriminant would be negative 4 squared minus 4 times 1 times 3. So we end up with 16 minus 12, which is 4. And 4 is positive. And because we have a positive number under here, it's going to be a real number. That's why we have real zeros. And we're going to add or subtract some number, which is why we have two solutions. That is what a positive discriminant tells me. I'm going to have two real solutions. I really should write the word real here. Let's make that say two real zeros. We'll just call them zeros, that way I can fit that in there. It tells me if my discriminant, if this number under the radical is positive, it's going to be real, and there's going to be two, because I'm going to add a number and I'm going to subtract that number, and I'll get two different answers. Let's see what happens to my discriminant here. A is 1, B is -4, and C is 4. So B squared would be -4 squared minus 4 times 1 times 4. Well, I end up with 16 minus 16, which is 0. Well, when you get 0 for the discriminant, when you have a 0 under this radical, there's just no number here at all. It just goes away. Oh, can't see what I'm doing. That means that I'm just going to use this eraser. That means that number just goes away, and you're just left with one number here, opposite of b over 2a, because the plus or minus part just goes away because it's 0. So we end up with one real 0. That's why we only have one real 0 when the discriminant is 0. So if the discriminant is positive, we get two answers. One where we add this number, one where we subtract. If it's 0, that goes away and we only have one answer, opposite of b over 2a. Let's see what's going to happen with this discriminant. A is 1, b is -4, c is 5. B squared is -4 squared minus 4 times 1 times 5. So I end up with 16 minus 20. I get -4. So the discriminant is negative. Well, when you put a negative under the radical, you get complex answers. And you're going to get plus and minus, so it's going to be two complex zeros. So we can put that there, two complex zeros. So let's actually find the zeros for this one. X equals opposite of b, so +4, plus or minus. I already know what the b squared minus 4ac is. I did it right there. -4 all over 2 times 1. So I get x equals 4 plus or minus the square root of -4 is 2 for the 4 and I for the negative, so 2i divided by 2. Now notice every one of these numbers can be divided by 2, so I get x equals 2 plus or minus I, because I divided each of these by 2. So I could say that one of my zeros is 2 plus I, and one of my zeros is 2 minus I. Those are my two zeros, 2 plus I, 2 minus I. So how do I write that as a factor? Well, the first factor, remember you always take x minus the 0, so x minus 2 plus I would be one factor, and x minus 2 minus I would be the other factor. So let's simplify, and that becomes x minus 2 minus I. I'll put parentheses around it, just like I always put parentheses around my factor. And this one would be x minus 2 plus I when I distribute that negative sign. So these are my complex zeros, and these are my